In this section, we will learn about steady state in a RL circuit. Okay, as we have seen in the previous section, steady state time is equals to 5 tau. Okay, tau is the time constant. Okay, the time constant, and in RL it's L over R. So if you want to know how long it takes to reach steady state, okay, for example, in these curves, we can say this point as the steady state. Okay, and tau is somewhere here. So 5 times tau, 5 times 1, 2, 3, 4, 5. This is called time constant, and 5 times the time constant is the steady state. Okay. So that's the first thing. The time to reach steady state is equals to 5 times tau, or that's 5 times the time constant. Now, what are the current and the voltage conditions at steady state? To find the value of current and voltage at steady state, we do not need to use any of the equations. Okay, it's very simple. The values are here. For voltage across the inductor, okay, voltage across the inductor at steady state, it's 0. You can see from the curve, at steady state the voltage becomes 0. The current across the inductor at steady state, here you can see the current here is E over R. E is the source here. Okay, this is 10, this is, if this is 10 volt, this is 2 ohms, then the current here at steady state will be basic Ohm's law, 10 over 2, which is 5 ampere. Okay, and current voltage across the resistor, okay, the voltage across the resistor is same as the voltage at the source. Okay, because there's no voltage drop here, the voltage is 0 volt, therefore all the 10 volt will drop across the resistor, and we can see from the curve here also same as this value. Okay, so that's all. It's very simple. At steady state, if you want to know the values, we just follow from this table. Okay, and it is also worth noting that at steady state, the inductor acts basically like a short circuit. You can replace the inductor with a wire. Okay, that's why there's no voltage drop across the wire. It's 0. Current is just the source Ohm's law. Okay, the current is E over R, and the voltage across the resistor is same as this because there's no voltage drop here. Okay, that's all. Thank you.